Alright class, today we're going to do a lot with geometry. First thing we're going to talk about is Pythagorean theorem. Hopefully you guys remember that Pythagorean theorem is a squared plus b squared equals c squared. And then when we're dealing with the unit circle, remember we made the radius equal to 1. And when we did that yesterday, we found out that x was just the cosine of theta and y was just the sine theta. So that means that the point is cosine theta comma sine theta. So when we use the move to the unit circle, this identity becomes cosine theta squared plus sine theta squared equals 1. So this is a very important identity. We're going to be using this a lot. You'll see it everywhere. Okay, real quick, we're going to talk about where things are positive. So hold on, I'll pause. Excuse me. So you can put all these down, and then I want to know where the things are that are positive. So in quadrant 1, all three of these are positive. Cosine is x, sine is y. When you divide those, you get a positive tangent. When you move to quadrant 2, x is negative, y is still positive, but when you divide a negative and a positive, tangent's negative. In quadrant 3, cosine's still negative, sine is now negative because we're down, excuse me, and then when you divide the negatives, you get a positive, so tangent's positive there. Over here, cosine's positive, sine's negative, and then when you divide, you get a negative. So what happens is, in quadrant 1, they're all positive. In quadrant 2, just sine is positive. In quadrant 3, tangent's positive, and in quadrant 4, cosine is positive. Now, if you start up here, there's a little phrase, all students take calculus. That's how you remember what's positive in which quadrant if you need to. Or you can just think about x is positive to the right and negative to the left, y is positive up and negative down. And then tangent, you just divide them. Alright, so we're going to use our new identity from before to find what sine of theta is. We know that cosine theta, again, squared plus sine theta squared equals 1. So I'm going to put in a 0.5437 for cosine theta. Again, you're not going to actually type in any sine button in your calculator. You're just solving for this piece. So you just need to figure out what that is. So when you move this over and square root it, basically you're going to be typing into your calculator the square root of 1 minus 0.5437 squared. And when you get that sine is equal to plus or minus 0.8393. Now be careful. Remember, this is saying that x is positive because it's positive. So if I look at my unit circle, x is positive 0.54 about there. That's in quadrants 1 and 4. So we need to find the y values we could have on the circle. Well, there's this one and this one. So I can go over this much in the x and then up and down in the y. Those are the two values we found. So when sine of theta is equal to positive 0.8393, we're up in quadrant 1. And when sine is equal to negative 0.8393, we're down in quadrant 4. So that would be my answer. Okay, I just used the identity to solve for what sine of theta is, and you do the same thing for cosine theta. So I know I need to find cosine theta. I know sine theta is 0.4828. By the way, this is y is positive, because again they're giving you a starting point that's positive. So that's quadrant 1 and 2. So we'll have to remember that later. Cosine theta equals plus or minus the square root of 1 minus 0.4828 squared, which you get 0.8757 plus or minus. So then if I draw my circle and think about this, the y is positive, so it's positive 0.48. So I need to figure out the two x values that'll get me there and there along that line. So the 1x value is positive 0.8757, and that's in quadrant 1. The other x value is the negative version of that, and that's in quadrant 2, because sine is positive. So we're just using our quadrants. Alright, so that's that. We're also going to use we're going to move outside the unit circle and just draw reference angles. So I have a 6 here, then I go 8 up, and then I draw the angle back to get this reference. Okay, so that's how you draw your triangles. The reference should be at the origin, not the right angle. Go X, Y, and then draw back. If you guys do not know how to get the hypotenuse, you use Pythagorean theorem. However, that's a special right triangle, so you should know that that's 10. Okay, h equals 10 when you solve that. So now you just do what we did in geometry. Sine is opposite over hypotenuse, which is 8/10, which simplifies to 4/5. Cosine is adjacent over hypotenuse, which simplifies to 3/5. And tangent is opposite over adjacent, which is 4/3. Okay? That pretty much is a geometry lesson. Alright, now we're going to draw this triangle. This means that it's going -4, so 4 to the left, up 6, and then back to the origin. So this is the reference theta that we're going to work with. You need to find the hypotenuse. I got rid of the negative just because it doesn't matter when you square it. You get 52 equals h squared. H is equal to square root of 52. You can break that down to 2√13. So this hypotenuse is 2√13. And now you can do what we did before. Set it up. So sine is opposite 6 over 2√13. You have to do two things here. You have to rationalize, and you have to simplify 6 divided by 2. So it just becomes a 3. So you get 3√13 all over 13 for simplifying that fraction. We have to do the same thing for cosine. Cosine is -4 over 2√13. Again, you have to rationalize. Cross out these, simplify those. So we get -2√13 over 13. And tangent is 6 over -4, which is -3/2. Okay? So that's just geometry. Alright, quick review for radians. Remember, 30 degrees is the same thing as 1/6 of a pi, because it's 1/6 of 180. 45 is a fourth, or pi over 4. And 60 is pi over 3. So we're going to just review using radians, so have those down. Try these on your own if you want first. I have a circle, kind of. 2 pi over 3 is not quite pi over 3. There's going to be a pi over 3 left. So that's a 60-degree reference. So this is 2 pi over 3. The reference is pi over 3. So if the reference is a 60-degree angle, that means the y is higher. So that means that x is the smaller number, y is the bigger number. Remember, your value is 1/2 and √3 over 2. And then look at what quadrant we're in. We're in quadrant 2, so x is negative. And that should be your final answer. And finally over here, -3 pi over 4 goes here, which means I have a reference of just pi over 4 left. That's my reference. Pi over 4 means that the sides are the same. So this is the one where they're both √2 over 2. But you have to be careful. We're in quadrant 3, so they're both negative. Cosine and sine are both negative there. Okay, so that is that.